The James Webb Telescope continues to surprise us with its incredible discoveries that force us to review our theoretical models and accept that we are in a new era of astronomy, where every week there are new surprising data that add to the pieces of a cosmic puzzle that we have to fit together again. Today we will discover strange objects, distant planets, but the most intriguing thing is what happens near the edge of the universe, where thanks to the powerful infrared vision of the James Webb, a cosmic panorama is being observed with enigmatic objects that we had never seen before. But we are not only intrigued by what happens at the edge of the universe. Astronomers are surprised to discover an unrecognizable cosmos that affects matter and time, with great implications for our future. We are entering unknown territory, in this prodigious time machine that immerses us almost to the beginning. The most distant galaxy. The James Webb Space Telescope has surpassed all limits, 13.48 billion light-years in the past. The light from a distant and ancient galaxy that existed 290 million years after the Big Bang. This galaxy is very far away and difficult to see due to the redshift of its light, an effect of the expansion of the universe. This galaxy was first identified in 2023, but now, with subsequent studies, more data has been provided. It is very bright and large, with a diameter of about 1,600 light-years and hundreds of millions of times more massive than the Sun. This suggests that it has many young stars and not just one massive black hole. It is incomprehensible how such a massive structure can be created in less than 300 million years. If the theory of the miniature universe is correct, it means that we are seeing one of the largest galaxies of that time, which were between 100 and 1,000 times smaller and denser than today's. The most surprising thing is that oxygen has been detected, and that means that previously there were population 3 stars that exploded as supernovae and enriched the interstellar medium with objects heavier than hydrogen and helium. Ariel. Our journey begins in our outer solar system, in the region of the gas giants. Astronomers have focused the James Webb on Uranus satellite Ariel, an enigmatic moon that has been very little studied with a diameter of 1,157 kilometers. The results have confirmed that its surface has deposits of carbon dioxide, the largest in the solar system. But due to the low pressures and its temperature, the CO2, also called carbon dioxide, should be a gas and be lost in space. So there must be some source that emits it continuously. Before the James Webb, it was believed that this gas was produced due to Uranus' magnetic field and charged particles from the solar wind bombarding the surface of Ariel. But the James Webb has detected something very different. The most probable conclusion is that there is an underground ocean of liquid water. 20 scientists from different international institutions have been astonished, and the results have been published in the Astrophysical journal Letters. The conclusions are that this mysterious moon has large quantities of carbon dioxide, but also carbon monoxide. CO2 forms a layer of up to 10 millimeters thick on the ice on the surface of the moon. This means that gases come out of the interior in the form of cryovolcanoes, forming large columns of material that rise up to thousands of kilometers to the magnetic field of Uranus. There is evidence that the surface of Ariel has cracks and scars that could be the result of cryovolcanoes that emit frozen mud instead of lava. The curious thing is that these scars and the carbon dioxide and monoxide are found on the side of Ariel that is not facing Uranus, so everything fits. The analysis of the James Webb has found something else. The presence of carbonates, salts that form when liquid water interacts with rocks, which supports the hypothesis of the underground ocean. 40 years ago, humanity sent a spacecraft to cross the skies of Uranus. Since then, this frozen giant has remained silent, jealously guarding its secrets. Today our most advanced instruments, such as the James Webb Telescope, have given us a glimpse of the wonders and suspicions of Ariel, one of its enigmatic moons. But this is just the beginning. Photographed by Epsilon India B. James Webb is similar to a spacecraft observing distant worlds, but without leaving the solar system. At 12 light-years we have found a strange world that is difficult to detect for terrestrial telescopes. It is a cold Jupiter with more than 6 Jupiter masses. A real monster. But the most surprising thing is that it has been photographed directly. That is, we detect most exoplanets by indirect methods and those that are closer to their star. These methods provide indirect evidence based on the attenuation of the star's light and its gravitational effects. So observing this type of planet is complicated, because they are very far from their stars and do not cross in front of them. This study has been carried out by Elizabeth Matthew of the Max Planck Institute for Astronomy in Heidelberg and published in the journal Nature. Having a direct photograph of an exoplanet in the light of a star has been very difficult until now, and very few have been photographed. The planet called Epsilon Indiae b orbits a red dwarf star called Epsilon Indiae in an orbit that varies between 20 and 40 times the distance from the Earth to the Sun and takes at least 200 years to orbit it. The James Webb's MIRI mid-infrared camera was used, equipped with a coronagraph that blocks the light from the star, allowing the nearby planet to be seen, which marks a milestone in astronomy in being able to detect them. The direct image has revealed heavy elements, specifically carbon, also methane and carbon dioxide and monoxide. If you want to understand this, imagine if the James Webb were on a distant planet 12 light-years away and observed the solar system. What would it see? Assuming that it had an ideal perspective and that the planets passed in front of the Sun, it could only detect Jupiter, and with the help of several telescopes, it might be able to detect Saturn with indirect methods, such as transit and radial velocity. The result of their atmospheres would tell us that they contain methane hydrocarbons. So as you can see, there are a lot of planets that we are missing, and only ideal observation conditions allow us to detect a small part of our universe. The most distant supernova. James Webb is like a time machine. The further away you look, the further back in time you see, and that's because light takes a while to reach us. This time we're going much further. On this trip into the past, astronomers have discovered the oldest supernova in history. A supernova is the explosion of a massive star 8 or more times the mass of the Sun and is difficult to detect due to its luminosity and lifetime. This supernova is about 12 billion light-years away. That is, a supernova from 12 billion years ago. This tells us what the early universe was like. But that's not all. The vision of James Webb has discovered 10 times more supernovae than ever before seen, including the most distant. According to the American Astronomical Society held in Madison, when analyzing the photographs they discovered at least 80 supernovae in a tiny region of the sky. Some of them are very old, from when the universe was only 2 billion years old. This shows what the James Webb can do. Not only does it see further back in time and with greater resolution, it also catches more light from the universe, 10 times more than the Hubble Space Telescope. If we could see the universe with our naked eyes, it would appear very dark. Objects are so distant that they are very faint, which is why we need large lenses in our observatories to catch as much light as we can. In the case of the James Webb, it can pick up infrared light that we can't see. We know there are many faint objects in the universe, like these supernovae, but we couldn't see them before, even with the most powerful telescopes. Edo Berger of Harvard University was amazed by the find. Imagine what might be out there if 80 supernovae were detected in a small region of the sky, equivalent to a tiny fraction of the size of the full moon. We can now see stars that exploded at different times in history, and with broader, less distant surveys of the sky, we're discovering about 10,000 supernovae a year. But those are easier to see because they're closer to Earth. Finding supernovae isn't easy. We have to take multiple images and look for discrepancies like light sources appearing and disappearing, called transients. And thanks to light observations and mathematical models, we can get precise information about when it exploded. The James Webb Telescope can detect ancient supernovae thanks to its ability to see in the infrared. The light from this supernova has been stretched by the expansion of the universe, and the redshift helps us figure out how old it is, so astronomers can study what the universe was like when it was younger. We're seeing the universe in its teens, long before the Earth existed. In the vastness of the cosmos we see supernovae, massive star explosions, stellar factories creating new elements essential for life, such as carbon and oxygen. If the stars did not explode, life as we know it would not be possible. Although these explosions occurred billions of light years away, their impact is deep and close. Every atom in our body and every corner of our planet carries with it the echo of a supernova, reminding us that we are intrinsically connected to the cosmos. Cosmic gems. We are reaching the edge of the universe, and we are in for a surprise. More than 13 billion light-years away, some 460 million years after the Big Bang, the James Webb Telescope found some strange structures. At first we thought they were galaxies, but a more detailed analysis revealed that it was a very old galaxy containing groups of stars distributed in a sphere. We have never seen star clusters so far away before. These clusters could be precursors to the globular clusters we see today in our galaxy, the Milky Way. The research has been led by the University of Stockholm and published in the journal Nature. The observation of this galaxy and its clusters has been possible thanks to gravitational lenses that act as cosmic magnifying glasses and occur when the light from a distant object such as a galaxy or a star passes close to a massive object that is behind and further away. The light, what it does is bend and enlarge the image of the more distant object. In this case, a galaxy cluster magnified the light from a galaxy called the cosmic gem arc. The Webb's observations revealed 5 compact points contained in the galaxy, distributed like a necklace along this arc, and each star is gravitationally bound to another at a maximum of 3.26 light-years, 1 parsec. If it weren't for the gravitational lens, we would have only seen a galaxy as a red, out-of-focus spot. We are approaching the epoch of regionalization, which is when visible light emerged in the universe, where the first stars emerged and galaxies began to shine and emit radiation that ionizes the existing neutral hydrogen. Today, those clusters will be much farther away due to the expansion of the universe and will have joined galaxies like ours. On the contrary, if someone saw us from that position, they would see exactly something very similar: star clusters and the formation of our galaxy in early stages. If there are other beings in the universe more than 13 billion light-years away, for them we would be at the edge of the cosmos. The first lights of the stars, the formation of our galaxy, the planet Earth, absolutely all the information of our past and present is traveling through the universe in all directions. That is the strange and fascinating thing about our universe. A universe in 4 dimensions, where any object must not only be located in space, but also in time. The edge of the universe. He has done it. James Webb has reached what we might call the edge of the visible light universe. This is an update on previous findings and has been carried out by a group of researchers from Penn State University. 3 bright red objects appear to us at the edge of the universe, about 13 billion light-years away, about 600 and 800 million years after the Big Bang. These objects are surprising for several reasons. They are very old galaxies when the universe was very young, and these objects seem to have stars much older than previously thought possible. Within these galaxies, supermassive black holes have been discovered that are 100 to 1,000 times larger than the black hole at the center of our galaxy. There are also stars that would have to be too old to exist in such a young universe. Current models of how galaxies and black holes form do not explain these findings well. According to these models, it should take billions of years for galaxies and black holes this large and old to form. These objects are breaking those expectations, and these galaxies are only hundreds of light-years in diameter, but as massive as the Milky Way. This means that we are observing that the past of the cosmos was a miniature universe, much more compact and smaller. The idea is that the stars were so close together that if we were in that primitive universe, the closest star would be in our own solar system. This supports the Big Bang theory, that everything was more united in a single point, although it does not explain how those galactic clusters could have formed so soon. Personal conclusion. My personal conclusion is that the James Webb is revolutionizing astronomy by providing some amazing data about the solar system, exoplanets, and distant galaxies. It's almost as if we traveled there. In addition, this tells us that the universe was formed much faster than the time estimates and galactic formations, that everything was much smaller and with denser structures than now. Since matter was so tightly bound, I suspect that light was bent due to the greater curvature of space-time, and time passed more slowly compared to the current era. These effects are key predictions of the theory of relativity. As the universe expands, density decreases, the curvature of space-time is reduced and time normalizes in relation to our current experience. Our nature is quantum, tiny, and we have been from the smallest to the largest. Who knows how many levels may still exist before us in an expanding cosmos? With these new findings, the James Webb Space Telescope does not disprove the Big Bang theory, which remains the most robust and accepted explanation for the origin and evolution of the universe. However, the observations we have obtained reveal something astonishingly deeper. The discrepancies between what we see and what we expected suggest that our understanding of the cosmos is incomplete. In every corner of the universe, in every distant galaxy, and in every nascent star, human curiosity continues to encounter new challenges. These challenges are not failures, but rather open doors to new questions. They remind us that science is a never-ending quest, a journey into the unknown, driven by the wonder of discovery beyond our current limits.